Hello my dear children of class 11 science. Today we do again continue with the chapter that we already started from the last class, wave. Now wave is one of the important chapter under unit number 10. Okay, the unit that we are doing is called oscillation and wave. This is unit number 10 and the chapter that we started from last class, that is wave. Now in today's class we do start with the terms related to waves. Yes, because in the last class you learned what is wave, what are the types of wave, especially a transverse wave, longitudinal wave you learn. Then after even you learn about the wave motion and the characteristic of what motion, wave motion. Okay, now we have a topic now to discuss terms related to waves. The children, you know that when a transverse or a longitudinal wave propagate or it may pass through a medium, then all the particles of the medium, remember this, all the particles of the medium oscillates or vibrate in the same manner. But the phase of the oscillation, changes from particle to particle. Some particle vibrate with maximum amplitude, some particle vibrate with less amplitude. Okay, but remember this much, that transverse wave or longitudinal wave always occur by the vibration or oscillation of all the particles of the medium. Okay, but they vibrate in a what manner? A periodic manner or in a certain manner, regular manner. Okay. Now when they occur a vibration, there are number of terms that we can define. Okay, number of terms that we can define related to this transverse or longitudinal wave. Now one of the first term that we define and try to understand is called the amplitude. One of the first term that we need to understand is the amplitude of the wave. The amplitude. Now amplitude actually defined as the maximum displacement. So I write down, it is nothing but the maximum what? Displacement. Okay, this is the maximum displacement. Okay, displacement through which, maximum displacement through which oscillating particle, okay, oscillating particle of the medium, undergoes on either side. On what side? Either side. Okay, from its what position? From its mean position. Okay, let me use the word mean, also called equilibrium position. Equilibrium what? Position. Okay, mean or also called what position? We call equilibrium position. Okay, that means when a particle of the medium oscillate in such a manner from the mean position in such a way so that if any particle acquire a maximum displacement, from the equilibrium mean position, then that maximum displacement of the particle, oscillating particle, in a transverse wave or longitudinal wave, okay, from either side from the mean or equilibrium position is called amplitude. So amplitude simply refers the maximum displacement. Okay, maximum what? Displacement. Now amplitude, as you know, it is symbolized by letter A. It is denoted by a letter that we use is A, small letter A. Okay, now I can show with a diagram also what is amplitude. Okay, now let me just take the example of a graph which I plot now, and these are displacement distance graph or displacement time graph. Okay, let me use the word displacement distance graph. Let me just do it first. Yes, time also will do it. And this is a displacement distance graph. Displacement, and this side is what? Distance graph. And now I'll draw the nature of one of the type of wave that is called a transverse wave. Which type of wave I'll draw? A transverse wave. And you know transverse wave always acquire a wave motion this way. The wave nature of the transverse wave is like this. So if you look at the wave nature of the transverse wave is this, then the wave is propagating in this direction. See, transverse wave means the wave in which the particle vibrate perpendicular to the direction of propagation wave. Perpendicular to the direction of propagation wave means if the wave propagates in this direction, the particle vibrate, say this way, up and down, oscillating or vibrating up and down, which is perpendicular to the direction of propagation of wave. If the wave propagates in this direction, the vibration takes place this manner. So that means the different particle of medium vibrate in a what manner? In a similar manner, but okay, but the change of oscillation changes from what? The oscillation, or that means the phase of oscillation changes from particle to particle. The phase means in the position in which the particle oscillate changes from particle to particle. Means some particle vibrate, oscillate less, some particle oscillate more. Some particle vibrate, oscillate in the positive side, some particle oscillate in the what side? Negative side. But if any one particle acquire a displacement, and this displacement will be maximum, and this displacement which is maximum on from the either side of the mean position, and that displacement is only called amplitude. So this line refer the equilibrium of mean position, so that the particle vibrating up and down, say like the example, the particles at this position, one particle vibrating this direction, some particle vibrate this direction. At this case, the particle vibrate this direction, some particle vibrate this direction, some particle vibrate this direction. Okay, so this arrowhead says that the particle are vibrating perpendicular to direction propagation wave. So in this case, if any one particle acquire a maximum displacement, see this is the maximum displacement. This side is displacement axis from the equilibrium position, not only on the positive side, also on the what side? Negative side. On either side, this is negative side and this is positive side. Then this maximum displacement occurred by the vibrating particle on either side from the mean position is simply called as what? Amplitude. So this makes the amplitude of the wave. Okay, and this amplitude, as I said, it is denoted by letter A. It can be measured by centimeter or meter, like that. I know. Okay. Now the next wave, the next term, that we can define is called time period. We define is called time period. Now time period is basically symbolized by letter T, capital letter T. Now time period is nothing but the time taken. It is nothing but the time taken by a medium particle. Time taken by a what? A medium particle. Medium what? Particle in completing. Particle in completing one oscillation is called time period. So when a wave propagates in any of the direction, okay, they are the medium particles which vibrate. So that means to have one complete oscillation of this vibration, okay, definitely there is a time which is taken, and that time taken by the medium particles in completing one vibration or one oscillation is simply called as time period, or simply called as what? Time period. Now this time period can be even expressed and measured in the form of with the help of graph. Okay, let me just draw the graph. Okay, this is again a graph called displacement time graph. Now this is displacement time graph. Now time is along x-axis. Okay, and let me just take this is a displacement. So this is a displacement. Okay, now I draw the same nature. This is a transverse wave. It goes this way. Okay, now in case of transverse wave, particle start vibrating from this medium, and when the particle have one complete vibration means this one's half vibration, one vibration. This is one complete vibration from here to here. When the particles of the medium when start vibrating and at this point, okay, this is one complete oscillation. So for one complete oscillation, whatever time that is required to have a vibration of the particle for one complete oscillation, that is called time period, and we mark by letter T. So this time is called time period. This time is called what? Time period. But children, you have learned that time period is also the time taken to have two consecutive what? Crest or torque. Two consecutive crest or torque. Now in case of transverse wave, as you know that this is the crest, this is the crest, and time taken to have two consecutive crests is called time period. This is also time period. So when one crest is formed, then another crest is also formed. So definitely time taken by the particle to form two consecutive wave crest is called time period, because this time period and this time period will be same. Similarly, this is true for another torque also. The time taken to have two consecutive torque is this side. Okay, another torque may be formed, and that distance is also called time period. That time interval is also called what period? Time period. Okay. Now next term that we define, children, under this wave is called frequency of wave. Now frequency is expressed by symbol n, small letter n. Sometimes we write small letter f or sometimes we write nu also. This is the symbol. These are the symbol we use for representing the frequency of a wave. Now what is frequency of the wave? The frequency of wave are nothing but the number of oscillation. Let me just write the statement. It is the not. Frequency of wave is the number of what? Oscillation. Number of oscillation made by a medium particle. Number of oscillation made by the medium what? Particle. Okay. In how many second? 1 second. Now just look at it. In just 1 second, how many number of oscillation or how many such type of wave, this type of wave can occur, or number of oscillation can made by the medium particle, that actually measure the frequency of the wave. So this is one oscillation. So this type of oscillation can be made by the medium particle in just 1 second. Just look at it, just in 1 second, and that defines the frequency of the wave. Okay, and frequency is marked by letter n or f, or we can use nu also. But children, you know that when you know the time period, the frequency can be expressed, and frequency is the reciprocal of what period? Time period. So when you know the time period, frequency is measured as the reciprocal of time period. And you know this frequency is measured by the unit hertz. We use the symbol unit hertz for measuring the frequency of wave. But we measure also as the reciprocal what period also? Time period. Now we have another term even we can define and measure related to wave, that is called wavelength. So let me just add somewhere out here only wavelength. Okay. Now wavelength is symbolized by lambda. So this is the symbol you have seen using what? Lambda. Okay. Now wavelength is nothing but the distance moved by the wave in the time of one complete oscillation. So to have one complete oscillation, how much distance traveled by or moved by the particle of the medium to have one complete wave, and that define the wavelength. Okay, so for that, this is the one complete oscillation. So starting from here, this is one complete oscillation. Definitely there is a distance moved by the particle to have one complete oscillation, and that is called wavelength. So from here to here is called wavelength. This distance that we measure under the wave is called wavelength. But children, remember this, wavelength is also measured as the distance between two consecutive crests. This is also wavelength. So this distance is also called wavelength. Or distance between two consecutive torque also. So if I add another torque out here, then this torque and this torque distance is also called wavelength. Okay, so wavelength can be measured by centimeter, it can be measured by meter, but as for the wavelength is concerned, we measure even in the what unit called Armstrong. You can measure in nanometer, measure in meter, centimeter, and so these are the unit that we use for measuring the wavelength. Okay. Similarly, we can define another term related to this wave, and let me just add somewhere out here only. This is called phase. Phase, and we mark by letter phi. We mark by letter what? Phi. Now phase is actually nothing but it acquires the position. Phase actually determines the position and the direction of the particle under the wave at any instant of time. That's why the phase of an oscillating particle at any instant of time actually denote the position and the direction of the motion of particle at that instant of time. And we actually measure by the angle. It can be in radian, it can be measured in degree also. Okay, but phase refer the what? Position or the direction of the particles. Okay, the phase refer the position or direction of particles. Now in order to understand what is actually phase, okay, in a wave, let me just mark this diagram by the particles. Position of particle by letter A, let me mark this by letter B, C, this is the position of particle at C, say D, this is say E, okay, this is what? F, it will go on and on, G, like that. Okay, so if you look at this diagram, I have marked with the alphabet A, B, C, D, E, F and all, G. These are all the position echoed by the particle, and even it echoed the direction of the particle. Okay, now if you look at this diagram, okay, if two particles of the medium at any instant are in the same distance, in the same direction from the equilibrium position, are moving in the same phase. They are moving in what phase? Same phase. So example, let me just give you one example. Okay, if one particle is at this position B, moving in this direction, another particle also at this position B, moving in this direction. This position, as you know, these are the crest, but the position acquired by the particle is maximum from the equilibrium position, and this position which acquired by the particle are in the same direction and at the same position. That means these two particles have the same phase. They have the what phase? Same phase. But if I take one particle is at B, another particle is at D, you can see the particle at B acquire the position or maximum position on the positive side, displacing in this direction, acquiring vibrating in this direction. Another particle acquire a maximum position on the negative side, but directing this side. That means these two particles acquire the same amplitude, the same displacement, but their directions or vibration are different. That means these two particles are opposite in phase. B and D are in opposite phase, like B and F are in same phase. But phase actually implies the position acquired by any particle of the medium at any standard time, and it also acquires the what? Direction. Now we define the last term related to wave, that is called wave speed, also called wave velocity. Yes, it is actually nothing but the distance traveled by a wave in 1 second. So how much distance that traveled by the wave in 1 second, just in 1 second, how much distance traveled, that is called wave speed. And this wave speed is marked by small letter B. So small letter B is the symbol we use for wave speed, or we also call wave velocity also. It's also called what velocity? Wave velocity. But children, remember this wave speed or wave velocity is the distance traveled by a wave, just in how many seconds? 1 second. So if this wave, which is progressing in a particular direction, acquires certain distance in 1 second, just in 1 second, and that distance traveled by the wave acquired by the wave in 1 second is simply called as wave speed or wave velocity. So as far as the medium is concerned, in a particular medium, the wave speed or wave velocity is same in all the directions in a medium. Okay, so these are the terms related to the wave. Now we go to the next topic, the relation. Actually, we derive the relation between frequency, wave velocity, and wavelength, and that part we do in the next YouTube video.